Rocket fuel power. Most people know hydrogen peroxide as that brown bottle of 3% solution you keep under the bathroom sink for scrapes and cuts. That version is harmless enough that you can pour it directly on your skin. But when you concentrate hydrogen peroxide up to 80 or 90%, you're dealing with something completely different. At these concentrations, it becomes what's called high test peroxide, or HTP, and it's powerful enough to launch rockets. The Germans used it in World War II for the Messerschmitt 163 rocket plane, and it's still used in some rocket systems today because it breaks down into oxygen and steam when it touches a catalyst, producing a massive amount of thrust. The problem is that concentrated hydrogen peroxide is an extremely aggressive oxidizer. If it touches your skin, it doesn't just sting like the drugstore stuff. It causes deep chemical burns almost instantly, bleaching tissue white and destroying cells on contact. The oxygen release is so violent it can literally boil your flesh. Even worse, if you spill it on anything organic like wood, cloth, or skin, it can trigger spontaneous combustion. The material just bursts into flames without any ignition source because the peroxide is forcing so much oxygen into the reaction. This makes handling high-concentration hydrogen peroxide incredibly dangerous, requiring specialized equipment and extreme caution, because one mistake can leave you with third-degree burns or an unexpected fire. The blonde bombshell. Hydrogen peroxide started showing up in hair salons in the late 1800s, but the real explosion came in the 1920s and 1930s, when Hollywood made platinum blonde hair wildly popular. Actresses like Jean Harlow became famous for their near-white hair, which earned them the nickname peroxide blondes. The chemical itself is pretty simple, just hydrogen and oxygen bonded together in a way that makes it unstable and reactive. When you apply hydrogen peroxide to hair, it breaks down into water and oxygen. That oxygen is the key player here. It penetrates the hair shaft and attacks the melanin pigments inside, which are the molecules responsible for your natural hair color. There are two types of melanin in hair: eumelanin, which makes darker colors, and pheomelanin, which makes reddish tones. The oxygen literally breaks apart the chemical bonds in these pigments, destroying their structure and turning them colorless. It's not a gentle process, which is why bleached hair often feels drier and more brittle afterward. The peroxide essentially oxidizes the melanin into smaller, colorless compounds that no longer reflect color the same way. Hair dye products today still rely on hydrogen peroxide for the same reason. It works, it's cheap, and chemists haven't found anything better at stripping natural color so new dyes can take hold. Most box dyes and salon treatments use concentrations between 3 and 12%, with higher percentages giving faster and more dramatic results, but also causing more damage to the hair structure itself. Wound bubbling mystery. When you pour hydrogen peroxide on a cut, that fizzing and bubbling you see is actually a chemical reaction happening right there in your wound. The hydrogen peroxide molecule is made of 2 hydrogen atoms and 2 oxygen atoms, written as H2O2, and it's inherently unstable. Your body contains an enzyme called catalase that exists in pretty much every cell, and when the hydrogen peroxide touches your damaged tissue, the catalase immediately starts breaking it down into water and oxygen gas. Those bubbles are pure oxygen being released from the reaction. The more the wound bubbles, the more organic material and cells are present to trigger the breakdown. Dead skin, bacteria, and blood cells all contain catalase, so a really dirty or infected cut will foam up more dramatically than a clean, shallow scrape. For decades, people thought this bubbling action was cleaning the wound by lifting debris out, and the oxygen release was killing bacteria. The truth is more complicated. Hydrogen peroxide does kill some bacteria, but it also damages your own healthy cells in the process. The oxygen bubbles can help flush out loose dirt mechanically, but the chemical itself can actually slow down healing by destroying new tissue cells trying to form. Modern wound care generally doesn't recommend hydrogen peroxide anymore because the cell damage outweighs the cleaning benefit. Soap and water or saline solution are considered better options now. The bubbling looks dramatic and feels like something productive is happening, but that foam is partly your own cells being destroyed along with the bad stuff. White blood cell factory. Your body is basically a chemical weapons factory, and your white blood cells are the ones running the production line. Every time a bacterium or virus tries to set up shop in your body, certain white blood cells called neutrophils and macrophages respond by manufacturing hydrogen peroxide right on the spot. This process is called a respiratory burst, which sounds dramatic but really just means the cell rapidly sucks in oxygen and converts it into H2O2 and other reactive molecules. The white blood cell engulfs the invader in a pocket called a phagosome, then floods that pocket with hydrogen peroxide. The concentration can reach levels high enough to rip apart the bacteria's cell wall or shred viral proteins. It's a direct chemical attack happening inside your body thousands of times a day without you feeling anything. The hydrogen peroxide doesn't stick around long because your cells also produce an enzyme called catalase that breaks it down into water and oxygen once the job is done. This keeps the H2O2 from damaging your own tissues. Essentially, your immune system has figured out how to weaponize a simple molecule, deploy it precisely where needed, and then neutralize it before it causes collateral damage. This whole system has been operating in animals for millions of years, and it's one of the oldest and most effective antimicrobial strategies evolution came up with. You're walking around with a built-in disinfectant system that's more targeted than anything you can buy at a pharmacy. The concentration danger. Let me proceed with writing the chapter based on established medical and chemical safety information about hydrogen peroxide concentrations. The bottle under your bathroom sink is probably 3% hydrogen peroxide, and that concentration is weak enough to rinse your mouth with or dab on a cut without much drama. At 3%, the peroxide releases oxygen slowly, and the amount of tissue damage stays minimal. You might get some brief whitening of the skin if you spill it, maybe a little stinging, but nothing serious. The real danger starts when you jump to concentrations above 10%, which is where industrial and some alternative medicine products live. At 10 to 12%, you're looking at hair bleach strength, and this stuff will chemically burn skin on contact if you don't rinse it off fast. Go higher to 35%, sometimes sold as food-grade peroxide, and you're dealing with a corrosive liquid that eats through tissue aggressively. If someone swallows high-concentration peroxide, the liquid releases massive amounts of oxygen gas as it hits the wet environment of the mouth, throat, and stomach. This creates foam and bubbles that can block airways, rupture the esophagus, or tear holes in the stomach lining. The chemical burns start immediately, destroying tissue layers and causing internal bleeding. People have died from drinking just a few ounces of 35% peroxide because the damage happens too fast and affects too many systems at once. The concentration makes all the difference between a harmless household product and something that can kill you in minutes. Food-grade poison. Myth. Some alternative health circles promote drinking diluted food-grade hydrogen peroxide as a cure for everything from cancer to infections. The logic sounds almost reasonable at first. You can buy 35% hydrogen peroxide labeled food grade, which means it doesn't contain the stabilizers found in regular drugstore peroxide. Proponents claim that diluting a few drops in water and drinking it floods your body with oxygen, supposedly killing disease. This is dangerous nonsense. Food grade just means the product is free of certain additives, not that it's safe to consume. The term refers to uses like sanitizing food processing equipment or bleaching flour, not drinking. When you swallow concentrated hydrogen peroxide, even diluted down, it starts decomposing immediately in your stomach and releases oxygen gas rapidly. This creates foam and bubbles that can stretch and tear the esophagus and stomach lining. The oxygen can form emboli, which are gas bubbles in your bloodstream that block blood flow to vital organs. People have died from strokes and heart attacks caused by these emboli after drinking hydrogen peroxide. The chemical also causes direct burns to tissue. Documented cases include perforated stomachs, seizures, and respiratory failure. The FDA has specifically warned against this practice multiple times. What you're doing is drinking bleach, essentially, just a different kind. The fact that something has food grade on the label doesn't make it food. Industrial salt is food grade too, but you wouldn't eat handfuls of it. Sterilization. Superhero. Hydrogen peroxide is one of the most versatile sterilizing agents used today, and it shows up in places from hospital operating rooms to spacecraft assembly facilities. In medical settings, vaporized hydrogen peroxide sterilizes surgical instruments and entire rooms by flooding them with a fine mist or vapor, usually at concentrations around 6 to 7%. The process can take anywhere from 30 minutes to a few hours, depending on the space or equipment being treated. What makes hydrogen peroxide so effective is its oxidizing action. When it contacts microbes, it breaks down into water and oxygen. But during that breakdown, it produces reactive oxygen species that attack the cell walls and DNA of bacteria, viruses, and even hardy bacterial spores. These spores are tough little packages that can survive extreme conditions, but hydrogen peroxide's oxidizing punch tears them apart at the molecular level. Hospitals like this method because once the peroxide breaks down, it leaves behind only water and oxygen, so there are no toxic residues to worry about. You don't need to air out a room for days or rinse instruments repeatedly. NASA has used hydrogen peroxide for decades to sterilize spacecraft components, particularly before missions to Mars where preventing Earth microbes from contaminating another planet is critical. The Viking landers in the 1970s had parts sterilized with dry heat and hydrogen peroxide vapor to meet planetary protection standards. It's a clean, powerful method that handles everything from scalpels to space probes. The contact lens cleaner. If you wear contact lenses, you might use hydrogen peroxide to clean them without even realizing how aggressive the chemical actually is. The most common systems use 3% hydrogen peroxide solution, the same concentration that bubbles and froths when you pour it on a cut. This stuff kills bacteria, fungi, and viruses on your lenses by essentially oxidizing them to death, breaking down their cell walls and proteins in a way that regular multi-purpose solutions can't match. The problem is that 3% hydrogen peroxide will do the exact same thing to your eyes if you put your lenses in without neutralizing it first. The burning would be immediate and severe, causing damage to your cornea within seconds. That's why these systems come with a special case that has a platinum disc or tablet built into the lens holder. When the hydrogen peroxide sits in the case for the required time, usually at least 6 hours, the platinum acts as a catalyst that breaks the hydrogen peroxide down into plain water and oxygen gas. You can actually see the tiny bubbles forming as this reaction happens. By morning, what was a harsh disinfectant is now completely harmless. The entire system depends on you following the timing exactly and never, ever rinsing your lenses with the peroxide solution and putting them straight in. People who skip the neutralization step or get impatient learn this lesson in the most painful way possible. Environmental breakdown hero. When hydrogen peroxide breaks down, it splits into exactly two things: water and oxygen. That's it. No toxic residues, no chlorinated compounds lingering in the environment, no harmful byproducts building up in waterways. The chemical reaction is almost absurdly simple. Each molecule of hydrogen peroxide, which is just H2O2, loses one of its oxygen atoms and becomes regular water, H2O. The leftover oxygen atoms pair up and become oxygen gas, which just bubbles off into the air. This breakdown happens naturally over time when hydrogen peroxide is exposed to light or heat, but it speeds up dramatically when it touches organic matter or certain metals. Either way, the end result is the same. You're left with plain water and breathable oxygen. Compare that to chlorine bleach, which produces organochlorines and other persistent chemicals that can contaminate soil and water supplies for years. Chlorine compounds don't just vanish. They stick around, react with other substances, and create secondary pollution problems. Hydrogen peroxide, on the other hand, essentially erases itself after it does its job. This is why it's become the go-to disinfectant for industries trying to clean up their environmental act. Water treatment plants use it, food processing facilities use it, even hospitals are switching over. The cleaning power is comparable, but when you're done, you're not dumping hazardous waste into the ecosystem. You're releasing water and oxygen, two things that were already there to begin with.